Prime factorization. So there's two ways that we talked about doing this, right? We're trying to make a string or multiplication sentence that of just prime factors that equals 24 and 120. We talked about the tree and breaking it apart or decomposing the number until we get prime numbers, or the upside down cake where we use division. So let's do both methods. Let's start with the upside down cake. So there's a bunch of different multiplication factor pairs that we could start with, but I'm just going to start with, I know that 8 times 3 equals 24. 3 is prime, so I'm going to circle it. It's done. 8 is not, so I'm going to put it in a box. 4 times 2 equals 8. 4 is not prime. 2 is prime. I'm going to bring down the 3 as well. So I'm going to break that apart. So 4 is the same as 2 times 2. That's prime, and then I need to bring down the rest of these guys too. Okay. Now if I multiply across, I should get 24 each time. 8 times 3 is 24. 4 times 2 is 8, times 3 is 24. 2 times 2 is 4, times 2 is 8, times 3 is 24. So if you do it right, each of your rows should multiply out to 24. Now, for the upside down cake, again, we can use our divisibility rules and division to help us out. You remember, if the number is even, we can divide it by 2, so I'll start with 2. 4 is an even number. 2 goes into 2 one time, 2 goes into 4 two times. 12 isn't prime, so I got to keep going. I'll switch it up. 1 plus 2 is 3, so that's divisible by 3. Right? If you add the digits and the number equals something divisible by 3, then the whole thing's divisible by 3. 3 goes into 12 4 times. 4 is even, so I can divide it by 2. 2. And 2 is prime, so I'm done. So that means that's the same as 2 times 3 times 2 times 2. 2 times 3 times 2 times 2. Again, there's a lot of different ways you can do it. It doesn't have to be in this order. But we do need to write the prime factorization as with exponents. So how many 2's do I have? It looks like I got 1, 2, 3, so I'm going to write that as 2 to the third power times, I only have 1 3, so I'd say 3 to the first power. Okay, for the next one, 120. So let's start with the tree. I'm going to just do, how about 12 times 10? 12 is not prime, so I'll put a box around it. I'll break that up into 3 times 4. 10 is not prime, I'll put a box around it. I'll multiply it as 2 times 5. 3 is prime, 4 is not prime, 2 is prime, 5 is prime. Alright, so I'll need to break this apart further. 4, put a box around it, is 2 times 2. I need to bring down all of these, right? So we need to make our tree. To make our tree, we need to bring down all these guys. Alright, so there we go. 3 times 2 times 2 times 2 times 5. Again, if I'm writing it the exponent way, I have 1, 2, 3, 2, so 2 to the third power, times 3, there's only one of those, times 5, there's only one of those. Alright, with the cake, remember it has to be prime numbers on the outside, so let's see, if I add them up, 1 plus 2 is 3, plus 0 is 3, so if I add up the digits, it's 3, so I know that's divisible by 3. That goes in 40 times. That's an even number, so I know that I can divide it by 2. So 2 times 20. It ends with 0, so I know it's divisible by 5. 5 times 4 equals 20. 4 is even, so 2 times 2. So that's my 3 times 2 times 5 times 2 times 2. Whew. 3 times 2 times 5 times 2 times 2. Again, I have 1, 2, 3, 2, so 2 to the third power, times 1, 3, 3 to the first power, times 5 to the first power, which I should write there.